Rhine refers to the nose, and itis refers to inflammation. So rhinitis is nasal inflammation. Allergic rhinitis is also called hay fever, because it's typically caused by allergens like hay, as well as pollen, dust, animal hair, or mold spores. Since the main trigger is pollinating plants, allergic rhinitis will flare up at specific times of the year. Allergic rhinitis is a type 1 hypersensitivity reaction, which is a type of allergic reaction that starts with exposure to an environmental allergen. So let's say that a bit of pollen enters the nose. It can get picked up by a dendritic cell, which is the type of immune cell that gobbles up the foreign particle and presents it to a nearby lymphocyte called a T cell. If that T cell gets activated, it kicks into action, producing cytokines which help to get other immune cells involved. The exact type of T cell determines the type of immune response, and in allergic rhinitis there's a bit of a T cell imbalance. There are too many T cells that, when activated, stimulate B cells, another group of lymphocytes, to produce IgE antibodies. Those IgE antibodies get released into the bloodstream and bind to mast cells, which are immune cells in the tissue that carry within themselves a load of histamine. Once bound by IgE, the mast cells are primed, meaning if pollen enters the body again in the future, those mast cells degranulate and release their histamine into the local tissue. The histamine causes blood capillaries to dilate and become leaky, which brings more fluid and immune cells to the area where the mast cells are located. Because the eyes and nose are portals of entry for infections, there are lots of mast cells around those areas for extra protection. So those IgE-primed mast cells release their histamine, which causes nearby capillaries to dilate, flooding the facial tissues with fluid. Interestingly, there's evidence that early exposure to allergens might protect against type 1 hypersensitivity. For example, children who grow up on farms and have pets at an early age typically have lower rates of allergic rhinitis. It's thought that a combination of genetic factors and environmental factors like these contribute to which type of T cell group is most common, and thereby influences the overall immune response. The symptoms of allergic rhinitis are related to excess fluid in the facial tissues. It causes nasal congestion and red, itchy, swollen eyes with frequent bouts of sneezing. Symptoms can start just minutes after exposure to allergens and can persist for weeks at a time, affecting the ability to concentrate and sleep, as well as attend work or school. The most common way to diagnose allergic rhinitis is through skin testing. One type is called the patch test, where allergens are applied to small patches and stuck onto the skin. If the skin under a particular patch becomes irritated, it suggests an allergy to that substance. Another type is called scratch testing, and it's when a small drop of allergen is placed on the skin and then pricked into the skin with a tool, again to see if there's evidence of an allergy like raised bumps or wheals, which is itchy red skin. These can test for a lot of allergens at once, but they can sometimes have low sensitivity as well as low specificity. In other words, sometimes a person might have no allergic reaction on the skin test, but have a localized allergic reaction affecting the nasal cavity and eyes. That's low sensitivity. Other times a person might have a skin reaction to something, even though they don't normally have symptoms when they encounter an allergen in their everyday life, and that would be low specificity. Typically, the best thing for allergic rhinitis is to simply avoid the triggering allergen if possible. If there are symptoms, antihistamine medications can be used to suppress the effect of mast cell degranulation. Nasal irrigation can flush out the sinuses, which reduces the congestive symptoms of allergic rhinitis. In some situations, it's also possible to rewire the body's immune response to an allergen by exposing it to micro doses and slowly ramping up to a full dose of the allergen. This gradually boosts tolerance to the allergen by reducing the immune system's tendency to produce IgE each time. Alright, as a quick recap. Allergic rhinitis is a type 1 hypersensitivity reaction which results in inflammation of the eyes and nose. Airborne allergens like pollen, dust, animal hair, or mold spores cause mast cells in the tissues to release histamine, causing the eyes and nose to get inflamed and watery. Avoiding allergens is the best approach, but it's also possible to use antihistamines, and in severe cases, try desensitization to reduce or eliminate the symptoms.
Hey guys, Vince here. I hope you found our video today on allergic rhinitis useful. If you'd like to do a deeper dive on this topic or other medically relevant topics, I encourage you to check out our website at osmosis.org. There you'll find other types of content like flashcards and quiz questions, but you'll also find resources that'll help you retain this information that you work so hard to learn in the first place. Tools based on things like the practice of spaced repetition. It's pretty cool and useful stuff. For the video today, the script was written by Fergus Baird. It was edited and given medical review by Risha Desai. Tanner Marshall performed the voiceover, and I created the illustrations. If you'd like to support more of these videos, I encourage you to like and share our videos on social media, subscribe to our channel on YouTube, or donate to us on Patreon. All right. Thanks a lot, guys. Bye.